Hello, everyone. My name is Marco Rossetti. I'm currently working at Trainline in London, but this work was developed when I was a PhD student at the University of Milano Bicocca, working with Professor Stella and Professor Zanker. So this work is about the comparison of offline and online evaluation of recommender systems. There are many works in the literature focusing on this topic, and both from an internal validity and external validity point of view. And most of them found that this is at least questionable. So the main contribution of this work is the comparison between offline and online evaluations, but using a within users experimental design, where we actually test the same algorithms on exactly the same users, both offline and online. So the research questions that we try to answer are about if we can use offline accuracy measurements to reproduce the rankings that come out from a user study. And the accuracy measurements that we use are precision, so the popular precision, and also precision on only long-tail items to try to remove the bias of very popular items. We also compare these two offline metrics with kind of a utility of recommendations, or how useful they are, which means if they're relevant and also novel to the user. So the study that we ran was consisted in two steps. In a first round, we asked students from our university to browse a web interface and mark movies they like. And in this way, we were able to collect 241 ratings from 241 users, and on average, 137 ratings per user. In a second round, we asked the same users to evaluate 4 algorithms with 5 recommendations each. So we basically created a list of recommendations for each user, mixing these recommendations from these 4 algorithms. And on average, each user said to evaluate 17.4 recommendations, because the same recommendation could be produced by more than one algorithm. And we also attached 2 fake recommendations at the end, which were actually items they liked in the first round, just to validate their responses. This way, we were able to, so 122 users returned to complete the second round, and after cleaning, we kept 100 of them. So how we compare then offline and online evaluation? So first of all, we train 4 different models on the MovieLens 1 million dataset, and we trade popularity as a normal baseline. 2 matrix factorization models with 80 and 400 latent factors, and an item-to-item k-nearest neighbor. So we picked 80 and 400 because 80 was the one performing best with offline precision, and 400 was the one performing best for precision on long-tail items. Then we evaluated this model on the offline data that we collected in the first round using all but one validation, and we computed precision on all items and precision on long-tail items. And we did the same with the data from the second round. So using the answers that the user gave, we were able to compute precision on items, precision on long tail, and also useful recommendations. Then we compare these metrics, and for instance, if we focus on precision, we found that we have different rankings of algorithms from offline and online point of view, where in the offline world, MF80 was the best, while in the online, MF400 was the best. We also show these domination graphs, where there is an edge from an algorithm to another when the algorithm is significantly better than the other. And so you can see that these graphs are different in this case. While if we focus on precision on long-tail items, so on not popular items, we can see that these precision on long tail items produce the same rankings in both offline and online scenarios, and also the domination graphs are exactly the same. In particular, it's interesting to see that MF400 is much better than the other algorithms, and it's something that didn't happen if you only consider all items. But finally, when we consider the utility of recommendations, so useful recommendations which are relevant and novel, we found that here the ranking was completely different, and the item-to-item was the best algorithm, and which is contrasting with what we found with precision offline, where actually MF80 was dominating item-to-item, while here it's exactly the opposite. So to conclude, the main contribution of this paper is the comparison of different algorithms, online and offline, based on within users' experimental design. And we found in particular that the algorithm performing best according to traditional precision offline was actually significantly worse when it comes to useful recommendations, so relevant and novel. And finally, we'd like to encourage academia and industry to keep working on this topic because it's very important to being able to validate offline experiments without having to run too many A/B tests, for instance. That's something that we would like to do at Trainline as well. Thank you very much.
I have a moment for a question or two. I see two of them both in the back left, middle section, and then the far section.
So appreciate you studying this topic. I guess I'm not sure that your experiment matches what people usually think of as online recommendation. I mean, I think ideally the user would experience the item and discover whether they liked it or not, and the recommender is going to kind of track that over time. I'm just wondering, short of building your own e-commerce site, if you have thoughts about how to, get a more valid kind of online recommendations experiments.
Yes, good question. Yeah, here with online evaluation, it was actually a user study created for this piece of research. Of course, yes, if you have an e-commerce or, for instance, Trainline, we basically sell train tickets, so we can create a recommender for destinations, and you can actually run online experiments and test it. So that's the plan, to compare offline experiments with these online experiments. But yes, if you have e-commerce, you can do. At the time I did this research, I was a PhD student, so we had to run a user study to do this comparison.
Sure. We got time for one quick last question.
Yeah, so I guess you mentioned that the precision-based offline metric was not correlated. Did you find any metrics that were correlated with offline and online performance?
Do I find what, sorry?
Any metrics that were correlated with offline and online performance?
So yeah, I mean, we tried different metrics, not only precision, also ranking measures and so on, and they were all quite correlated. So in the end, we decided to pick precision because it's the simplest, and it was working well, both from an offline point of view and in the user study.
Okay. Thank you. Thank you one more
Thank
time.
you.